So as the story goes, in the mid-1600s, there's an outbreak of the plague in Europe, and Isaac Newton, who was at college, I believe at Cambridge, goes home, and he's outside working in a pasture, and an apple falls to the ground. And he observes the apple falling to the ground, and at the same time observes the moon, and recognizes that the same thing that causes the apple to fall to the ground should be what's keeping the moon attached to the earth, essentially. And from that, he figured out that the gravitational force, what's called Newton's law of universal gravitation, he found that the gravitational force was proportional to the product of the masses of the two objects and inversely proportional to their distance squared. Now, later in the 1900s, the law was adjusted by a guy named Henry Cavendish, who was able to determine a constant that actually allowed for direct measurement of these particular forces. Newton determined the relationship, and Cavendish was just able to put numbers to it. So the universal law of gravitation just says that the force of gravity is equal to capital G times the product of the masses divided by the distance between them squared. G is what's called the gravitational constant, or the universal gravitational constant, and has a value of 6.674 times 10 to the minus 11 newtons meters squared per kilogram squared. When I work this, I generally just use 6.67 times 10 to the minus 11, and that's perfectly fine for you to use as well. Remember, mass is always positive, and gravity is always an attractive force. And so the force always points the direction towards the opposite object.